Assalamu alaikum, grade 9. Today we're going to be doing section 4.1, which is all about enlargements and reductions. So the first thing we're going to do is define what an enlargement is, because the working example 1 wants us to draw an enlargement. So an enlargement is an increase or any increase in the size of an object. Okay, but you have to keep in mind that you're changing the size in all directions. So if you have a square and you just increase it this way, that's not an enlargement. Okay, it has to be an actual identical design, but changed in all directions. So if this was our original, then this would be an enlargement. Okay, so it's changing in all directions equally. So example 1 tells us to draw an enlargement twice as large as the original. So it doesn't really give us anything to start off with. So I'm going to just start off with just an arrow design. So we're going to have an arrow like this. It's going to go 1, 2, 3, 4, 5 squares and another arrow here. And we're going to draw an enlargement of that. So the first method is to use a grid paper, which is what this is. So what you want to do is you want to count how many squares it takes up and then double it, because it says to draw it twice as large. So it takes up 1, 2, 3, 4, 5 squares. So the enlargement should take up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. And then in the last one, the arrow took up 1 square across. So in the enlargement, it would take up 2 squares across. And then same with the other side. Okay, so it changed in every direction. This part took up 1 square, now it takes up 2. This part took up 5 squares, now it takes up 10. And then same with every part of the design. Okay, so every single part of it got enlarged twice as much. So this is a true enlargement. If I just drew the line 10 squares long and kept the arrow 1 square across, it would not be an enlargement. Okay, so it has to be the same all across. How about if we draw another shape? Let's say this time it's a square that's 2 by 2. And the question says to draw 3 times as large. So 3 times means times it by 3. So if this was 2 times 3, that means it should be 6 in the enlargement. So I'm going to do it as 1, 2, 3, 4, 5, 6. And every side is getting multiplied by 3. So every side becomes 6, because 2 on every side times 3 is 6. So this would be an enlargement of 3 times the size of the original. Okay. Now, a reduction is our next definition. And a reduction is the opposite of an enlargement. A reduction is a decrease in the size of an object. Okay, so it's the same idea. You're just decreasing it by the same amount all around. Like in this thing, the shape didn't change. The object stayed exactly the same. It's just a smaller version of itself. So if we're doing it on graph paper, okay, again, let's do this time a rectangle. So this rectangle is going to be a 4 by 2 rectangle. Now the question says to draw 1/2 of the original, so cut it in half, which means that you're dividing everything by 2. So the length was 4, the width was 2, which means our new length is going to be 2, and our new width is going to be 1. You're dividing every side in half. So it's going to be like this. This rectangle would be a true reduction of 1/2 of the original. Okay, every side is reduced. This one says draw to a scale factor of 0.5. Now we haven't talked about the word scale factor yet. That's right here on the side. the definition of scale factor, which is probably the most important definition in the whole chapter, a scale factor is the number that you multiply by all dimensions of an object that's either enlarged or reduced. So when we enlarged an object twice its amount, its scale factor was 2. When we reduced it by half the amount, the scale factor was half, or 0.5. So whenever you have a scale factor that's bigger than 1, that's going to indicate that you have an enlargement happening, okay? If you have a scale factor smaller than 1, so these are decimal numbers or proper fractions, this would be a reduction, okay? And if you have a scale factor equal to 1, there is no change in the size of the object, okay? Multiplying anything by 1 doesn't change the number, okay? So no change in the object if the scale factor is 1. So let's go back to this question. This says, if you have an object, again, let me draw this time just a regular, let's say a number line. Okay, so I'm going to draw a number line that looks like this. I'm going to go to 6. And then 1, 2, 3, 4, 5, 6, 7, 8, and then 6. So let's say this is a huge number line, okay? And I want to draw it to a scale factor of 0.5. Well, let's take a look at all our dimensions here. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units, and this part is 6 units, and this part is 6 units. So a scale factor of 0.5 means you're multiplying everything by 0.5. So if we just do it here on the side, 8 times 0.5, that's the same thing as dividing it by 2, which is 4, and 6 times 0.5 would be 3. So if I wanted to draw the new image, it would be a reduction. Our 6's become 3, our 8 becomes 4, and it's going to be right here in the middle. So 1, 2, 3, 4, and then another 3 here. So now our dimensions are 4 and 3 and 3. And this is a reduction by a scale factor of 0.5. Okay? So that's it for 4.1, just these definitions of enlargements and reductions. Your assignment is from your textbook is right here to give you guys some practice with scale factors. This isn't enough practice, so you really need to go into your textbook and get that practice. Scale factor is the most important definition in the whole chapter, so you need to make sure you understand it. So please make sure you do these textbook problems to help you, and make sure you remember that a scale factor bigger than 1 is an enlargement, smaller than 1 is a reduction, equal to 1 means no change. And the other important thing is that when you're doing an enlargement or reduction, that you have to change it by both sides or all the sides. Every dimension changes. So not just one part, it has to be every single dimension in the object. Okay? And that's it, guys. That's 4.1. Assalamu alaikum.